Here we go with one last example of how to evaluate an indefinite integral. Now, once again, when you hear the word indefinite, that indicates there will be no limits on the bottom and the top of the integral sign. Therefore, your answer of an indefinite integral must always have the plus c constant at the end because you're giving the most general form of the answer. If it had limits of integration, numbers on the top and the bottom of the integral sign, your answer wouldn't have a c in it. It would be just a real number. Okay, so we're going to find the integral of sine theta over cosine squared theta d theta. Now, we have a problem here. The problem is that the integral does not appear on our table of indefinite integrals, note number 115. So we're going to have to work with it to get it, break it down into parts that do appear on the table, or parts that we can at least understand. So let's simplify the integrand. That's the function that we're integrating. The integral of sine theta over cosine squared theta d theta can be broken down to the product of two fractions, 1 over cosine theta times sine theta over cosine theta d theta. And then we can use a trig identity to write 1 cosine theta as secant theta and sine over cosine as tan theta. Now we know that the integral of secant theta times tan theta together appear on the table. The integral, in other words, the antiderivative of secant theta times tan theta, is equal to secant theta. And then don't forget to add your constant c. So we got that answer from the table, or for just remembering that the derivative of secant is equal to secant times tangent. In other words, secant theta is the antiderivative, the function, in other words, whose derivative equals secant theta times tangent theta.